Hello, apes. This lesson we're going to be talking about why there's an unequal heating of the earth and how that might contribute to climates and why they vary so much. So our objective today is to describe how Earth's processes determine the different climates across the globe. And our essential question here is, why do climates vary so much? So we're describing the difference between weather and climate as well. So here the difference between weather and climate. Weather is the short-term condition in our local area. So for today, it might be somewhat warm, sunny, with low wind. The next day, it might be different, where there's some clouds, maybe a chance of precipitation. Climate is the average of those weather conditions that occur in a given place over a long period of time, typically over the course of a year, or maybe several decades. So as the sun passes through the atmosphere and that light strikes the land and water, it warms the surface of the earth. But it doesn't occur evenly across our surface. The first reason why there is unequal heating is because the amount and type of surface area which the sun's rays are distributed. So heat is transferred through 3 different processes, and we'll talk about each one of these processes as we go. There's conduction, convection, and radiation. This is a diagram that shows kind of the differences between the 3. We'll talk about it a little bit more here. Radiation is the transfer of that energy by electromagnetic waves. You've seen this. This is actually what gives us our color spectrum. So there's different wavelengths, and so there's different ways that heat and energy can be transferred across Earth's surface. Sunlight energy tends to be a little bit more energetic, so we receive infrared radiation and ultraviolet radiation from the sun. The ultraviolet tends to be more high energy particles that reach our surface, and is part of the reason why we have to wear protection when we go outside. Because UV rays are so energetic that it produces a lot of heat and so can do damage to our skin. So another way that heat can be transferred is through conduction. While things are heating up, molecules bump into each other. As the temperature increases, those interactions also increase. This is common in solids. Energy is transferred from fast-moving molecules to the slow-moving molecules until every molecule is moving at the same exact speed. So an example of conduction might be touching a hot plate or the handle of a pan. That heat is being generated and then passed through that pan to that handle, and when we touch it, it could burn us. And that's the process of conduction. So land surfaces, as we determined here in our last lab for high specific heat, land tends to conduct heat really well, but doesn't hold on to that heat also. So the most heat that we can conduct is generally over land surfaces as opposed to the water. Convection is a little bit different from the others. It's that transfer of heat that occurs because of the differences in density. This is really common in liquids and in gas. and occurs in many locations here all over our planet, including inside of our mantle, throughout the oceans, and in our atmosphere. The second reason why we have unequal heating of the Earth is because some areas reflect more sunlight than others. This concept is referred to as albedo, not libido. Albedo is that fraction of radiation that is reflected by a surface. So fresh snow, obviously, you can see here, there's a lot more reflection of sunlight than there is from maybe a paved surface like asphalt. Water is also a really good reflector of sunlight. It's the reason why if you don't put on any suntan lotion when you go out to the beach and you go into the water, you're actually more likely to be burned by the sun while you're in the water than while you're suntanning out on the beach. So these are some of the different surfaces on Earth that reflect solar radiation and the varying percentage of albedo. So overall, on average, Earth's albedo is about 30%, so it's reflecting 30% of the sun's rays. More covered areas by trees and land are not going to reflect as much solar radiation than, again, like our snow, or depending on how many clouds we have in the sky, clouds also can reflect quite a bit of sunlight. Water, as I gave an example in the last slide, reflects quite a bit, 10 to 60%, as does sea ice. So this is just a review of the different percentages of solar radiation being reflected back into space as energy from the sun going back into space. 20% is absorbed by our atmosphere, and then 50% of that is absorbed by the land and the water, so it does not reflect at all. That 20 to 50% of the solar radiation that's trapped on the Earth is what drives a lot of our weather and quite a bit of our climate then as well. The last reason for unequal heating on Earth is that difference in angle of the sun's rays. Obviously, the equator is going to receive a lot more solar radiation than any other place on Earth because it gets the most direct sunlight, especially during our equinoxes. So our Earth has a tilt of 23.5 degrees. So that those polar regions, depending on which direction the Earth is facing the sun, those polar regions are really going to get very little solar radiation because of that angle. As I said before, the most direct sunlight is going to be received in those tropical regions. So again, as I tried to demonstrate in class, when the northern hemisphere is tilted towards the sun, that's our summer. It receives a little bit more sun than, say, the southern hemisphere, which is then tilted away from the sun, and they're experiencing then their winter. And this is all because of the rotation of our Earth at a 23.5 degree angle on our axis. This kind of explains, it gives a little bit of details into why we have our seasons. So in number 1 here, that's our March equinox. The sun is shining equally on the equator, directly on the equator, and distributing the same amount of sunlight to both the North and South Pole. At that point in time, the North and South Pole are receiving about 12 hours of sunlight and 12 hours of nighttime. So it's equal. And two, the northern hemisphere is tilted towards the sun. That's our summer. So the sun, or the direct sunlight, is then shifted northward to about 23.5 degrees north, or the Tropic of Cancer, and that's our summer. So for number 3, it goes back. We have a September equinox. Again, it's receiving about 12 hours of daylight and 12 hours of darkness, especially at the North and South Pole. And then in December, our hemisphere is tilted away from the sun. It's receiving less sunlight, therefore our temperatures tend to be a lot colder than in our June solstice, which is our summer. The northern hemisphere actually has, or the North Pole, has 0 sunlight. So there are days where it's total darkness. Likewise, in June, when the South Pole is tilted away, the South Pole is experiencing total darkness, while the North Pole is having 24-hour sunlight. The sun will not set on the June solstice. So that kind of gives us an idea here of why we have our seasons, why we're experiencing unequal heating from the sun, and the distribution of that heat across the surface of the Earth.